So last time we learned how to simplify, guys, this example, right? 335, and we just break it into products of fractions. We separate them like that as a products, and then we simplify each of the fractions. Now, thanks to Mr. O, he taught me another method called Gcf method. Okay, so we're going to do the same exact problem. Okay, so I even did. By the way, do you think doing a factor tree for these numbers is going to be always helpful? Yes. Okay, so he's going. He taught me a Gcf method. Okay, so let me show you that in a minute. Okay, so go ahead and write this again, and we're gonna go over this. Okay. So there are many names for this, but I like to call it Gcf method. So you see how we have a numerator and denominator? What you're going to do is you're going to draw an upside down division bar like this, and then put the numerator and denominator like this. On the first one is the numerator, second one is going to be a denominator. Okay, and you draw an upside down fraction bar. Not fraction bar, upside down division bar. Sorry, division bar. Okay, is that okay?
It looks like an L.
Or L, whichever you like to call it, doesn't matter. I like to call it actually division bar because you'll see why in a minute. Because what you're going to do first is you're going to look at the numbers, 35 and 56, and you're going to ask yourself, what is the GCF of 35 and 56? And since we did a factor tree, it's easy to see. Did anybody see what GCF of 35? It doesn't have to be GCF. We could just do actually a common factor. What's a common factor of 35 and 56? You don't have to come up with the GCF right away because you're going to keep going doing this way. Yeah, what do you think? 7. Everybody see that 7? So you do a 7. And what you're going to write on the bottom, anybody have any guess? Since it's upside down division bar, guess what's going to go there? Yeah.
On the left, it'll be
5. Yeah, exactly. It's as if you actually divide this numerator by 7. And whatever that's left, right? Just like division. So that's what you get. And whoops. And guess what? Don't you get 8x5 y z? Does that make sense? Are we okay so far? And now then after that, you draw another upside down fraction bar. Okay. So one of you said, why not then just do like, because I can see that x is another common factor, but let's just do it one by one. So we'll do it for a number first. Now, if there was another common factor, then you will keep going. Do we have another factor for 5 and 8 this time? For just the number 5 and 8? No. If we did have it, then you could kind of keep going. In other words, if this was like, I don't know, 50 and 8, then you know that 2 goes into both. You know what I mean? So you should have done one more time, but then we can't. So we're done with 5 and 8, right? There's nothing that's common to 5 and 8 other than 1. Okay, 1 doesn't really help us. Then guess what? We look at the x's. What is a common factor of the x's? Yes. X to the third. Why did you choose x to the third? Why not x to the fifth? Yes. Yeah. Does that remind you of something? When we choose x to the third instead of x to the second or x to the fifth? When we were looking for GCF, what do we do? Which exponent do we choose? The smaller exponent of the two common factors. Remember that? So that's why it's called Gcf method. Basically, you're doing Gcf, really. Then, guess what we're going to write? It's like as if you divided this. That's why I see upside down fraction bar. What do you think you get if I write x cubed here? What's left then if you divide this? 3 people, that's it? Anybody else? Yes. Caroline?
5 y. Well, do you put the 1?
You don't have to put 1.
Okay.
Yeah.
5 y z to the 6.
Uh-huh.
And then 8x squared y z.
That's exactly right. And do you see why I don't want to put 1? Because if I did, it looks like 51 or something. So I don't want to do that. Very good. So it's as if you divided x cubed into both of these, denominator and the numerator. Then we're done with x's, right? Then guess what we're going to do? Yeah. Y. So what do you think my common factor of y? Which y should I use? Yeah. Y to the first. And then of course you get 5z6 8x squared y. Anybody have any guess as to what we do next? Yeah. Z. How many z's will go into both of these? Only one of them, right? We choose the smaller exponent, so we write z. And Laura, what do we get? We may do that.
5z to the 5th and then 8x to
8x squared. X squared. Does that make sense? Now, does anybody see why I did it this way? Because, okay, now, could I go any further?
No.
No, I cannot, because nothing goes into 5z fifth and 8x squared, does it? Other than 1, of course. Okay, 1 is always going to 1 will always go into any kind of monomial. Okay, so then guess what? Yeah, does anybody see what? Yeah.
No, I have a question.
Yeah.
What if there's a more than one common factor?
Yeah, you just keep going. What do you mean by that?
Like, so if you do a factor tree and
Yeah.
there's more than one common factor, what do you
Yeah, in other words, I don't know. If this was like 50 or something like that, right? Then you would do this and write 2 will go into 50 and 8. You keep going until there isn't any common factor. Does that? No? Okay, if you had 50 z fifths and 8x squared, right? What goes into 50 and 8? 2. They're both even. Doesn't 2 go in? And then after that, you could, if something else might go in, whatever.
Oh.
You know what I mean? You just kind of keep going. We'll do one like that in a minute then.
No,
How about?
I mean that, when you do a factor tree, there might be more than.
Right, that's one. Okay, so we'll get to that. We'll get there. We'll do one like that in a minute. Okay, so guess what? Look at whatever that's left is what, guys? Anybody see? Yeah.
Wait, no, I had a question.
Okay.
So what she was saying, do you mean like you keep making it lower until you can't go?
Yeah, you keep going until you don't have any common factor. Does that make sense? That's exactly what I'm trying to say. Very good. Yeah.
So then on the bottom, that's the numerator and the denominator.
Yeah, this is your numerator and this is your denominator after you.
On the side.
Okay, hold on. Okay, that's right. Okay, you're very. So on the bottom, don't you have the numerator and the denominator now? So look, is this the answer we got before? Look, go back. 5 z fifths over 8x squared. We get 5z to the fifth, 8x squared. Does that make sense? So some people said, oh, that's a cake. These are your candles. Your candles are your numerator and denominator. I don't know. However you like to think of it. Does that make sense? Okay, so there's don't mix this up though at the end, right? If you think this is your denominator, guess what? Are you gonna get the right answer? No. Okay. And Cameron noticed something else too. What is this on the left? Somebody said these are then icings or I don't know something. What are these? Anybody recognize what that is? Madeline? That's your greatest common factor.
Oh my goodness.
So greatest common factor of the numerator and denominator is this. 7, you multiply them out, of course. 7x cubed times y times z. Does that make sense? So when you do your homework tonight, didn't they ask you to find GCF? Can we do this upside down division bar? Some people like to call it upside down cake. I don't know. However you like to remember it. It's like, you know, cake layered. I don't know. Okay, yeah, it doesn't have to be that way. But do you think you could do this for your GCF if you wanted to?
Of course.
Yeah. And going back to Judy's question, let's do one what Judy's talking about. So, are we okay with these? Any question? So let's do this one then together, using method 2, GCF method. Now, do you have to use GCF method? No.
No.
Okay, but you don't have to. You could just do the one the normal way. So, do you think a factor tree is helpful?
Yes,
Okay.
You that one? No.
No?
Caroline,
Oh.
It's not the same one. Oh, actually, let me make this z to the third over here. Sorry, can you add z to the third on the bottom? Okay, then, let's do a factor tree for 36. What goes into 36 is even, so yeah. Yes. You want to do 6 times 6? Can I? Yeah, okay. 6 times 6, that's fine. And so what about 6? 2 times 3 and 2 times 3. So do you think that's helpful when we do these things? Okay. All right, so let's do the upside down division bar. 36x cubed y squared z 52. I'm gonna write my denominator next. X squared y z cubed. Okay, so let's look at the numbers. What's common? What is a common factor? You don't have to like I said, you don't have to start with the GCF because sometimes you may not see that. You may not see it. So, Judy, what's the common factor of 36 and 52? They're both even, so what goes into both? 2. So let's write 2. And tell me what to write, Judy.
Wait.
So if you were to divide 36x cubed y squared z by 2, what do you get? 18 x cubed y squared z. Good. What about the other one? You can see right here. When you do factor tree, when you divide it by 2, don't you get 26?
26
Mm-hmm.
x cubed yz.
X squared, not x cubed. X squared
yz
yz cubed. Are we okay there, guys? Your question?
Wait, isn't it like 2 squared?
Yeah, if you saw that already, you could, 2 squared is 4. You could have done it with 4 if you wanted to. But yeah, but if you didn't see it, that's why you could keep going. Because I wanted to show that example where you could just actually keep going like this. Then, what goes into 18 and 26? They're both, again? Yeah. Yeah, 2 again. They're both even. So 2, how many times does 2 go into 18? 9. The rest is the same, right? Then what about 2? 26, it goes in? 13 times. Now, does anything go into 9 and 13? No. This is what you're asking, right, Judy? Okay, there it is. Okay, thank you for asking, because that helps. Now, since nothing goes into 9 and 13, guess what? We're going to move on to the variables. No, variables are easier. X to the what power? Square, because this is the third, this is the second power. So somebody tell me what I get on the bottom. Yes.
9
Mhm.
x y squared z.
Good. And then here?
13 y z.
Oh, x is gone, right? Because it's 1. Y. C cubed the third. Guess what we're going to do next? We're going to move on to now? Y. Y is the what power? So this is first, because this is the first, that's the second. So we get 9x, y, z, right? 13, y goes into y1, so you just left with z cubed. Guess what we're going to move on to now? Z to the what power? Again, just first. Okay, 9x, y here, 13, z. Who can tell me what this fraction becomes once you simplify? This whole thing then becomes, how about, Lara?
9xy over 13.
Good. 9xy over. Don't mess this up at the end, right? Don't put that on the bottom, then you get it wrong. 13 z squared. There you go. Now, if I ask for GCF instead of simplify this fraction, what if I ask for GCF of these two monomials? What would the GCF be? GCF. That's why it's called Gcf method. You see, you get, not only do you get to simplify, you get the GCF. Anybody? Who haven't I called? Emily?
2 squared
2 squared
yz.
x squared y z. And you got 2 squared because it's basically you multiply the one on the side, right? These were the common factors, remember? So what's 2 squared, by the way?
4.
Yeah, you should just write 4 then. Okay, 4x squared y z is your GCF. Does that make sense? Is this clear to everybody?
Yes.
Very good.